Random forest in Navure. Random forest is a classification algorithm that creates multiple decision trees during training. By introducing randomness in feature and data selection for each tree, it mitigates overfitting. The final classification is determined through a voting mechanism based on the outcomes of all the individual trees, resulting in a robust and accurate predictive model. We will illustrate how to use random forest in Navure with the IRIS dataset, a widely recognized dataset created by British biologist and statistician Sir Ronald A. Fisher in 1936. You can find this dataset in the test data repository, consisting of 5 columns. The IRIS column contains the names of 3 plant species, while the other 4 columns represent the sepal length, sepal width, petal width, values for 50 flowers of each species. Once the data file is open, click the Multivariate tab and click the Random Forest button. Select all numerical variables and drag and drop them into the Numerical Predictors panel. Then drag and drop the IRIS variable into the Class ID panel. Note that Random Forest also allows to include categorical predictors. To proceed, click on the blue Play button to display output options and additional settings. On the left, you can select the tables to display. On the right, you can specify the total number of trees. Usually 300 trees is sufficient, but you can also select other common settings, such as 500 trees. The CV replicates determine how many times cross-validation is performed. In each cross-validation, the dataset is divided into 10 folds, with each fold reserved for testing the classifier to derive performance indices. The tuning length, MTRY, specifies the number of different randomly selected features that are considered at each fold when constructing an individual decision tree within the ensemble. Important: when you initiate a classification procedure for the first time, Navure may request firewall permission to access networks. This access is essential as Navure utilizes parallel computing to enhance performance. Please grant the necessary access to ensure proper functionality. Random forest is a very CPU-demanding procedure. Don't be concerned if the process takes several minutes or even hours. It highly depends on the total number of cases, the number of features, the number of trees, the number of cross-validation repeats, and the number of cores your machine has to perform parallel computing. The first table shows the performance of the classifier. An accuracy of 100% means that 100% of the cases were correctly reclassified. This accuracy is calculated from the average of multiple cross-validation loops and provides a reliable assessment of the classifier's effectiveness. It's important to note that while cross-validation techniques improve our ability to assess the robustness of the classifier, the quality and size of the training data set remains critical. The second table is the confusion matrix shown as proportion of original cases in each class. As expected for accuracy, all classes were well classified. The third table, importance, shows the importance index that ranges between 0 and 100. This is an arbitrary scale. Just keep in mind that 0 does not mean that the variable is meaningless for classification, it says that is the less important. A useful point to see in this table is that after the first 2 features there is a huge decrease in importance, telling us that probably the first 2 features are enough. A word of caution: as with many other statistical techniques, when applied to observational data like this example, the contribution, or importance, of a variable to the prediction of a response, in this case, the species, is highly dependent on the set of variables included in the analysis. You may expect that if we drop the first 2 features from our last analysis, we will get a poor classifier, but on the contrary, we get a classifier as good as the previous ones. This case illustrates that the importance index does not have the last word.